Okay, here we're going to do some more practice with systems. Let's see how you do. So the first one, notice it's already got this isolated y equals an isolated variable. So it's set up nicely to use the substitution method. All right, so substitution means that we're going to take this entire part back here and we're going to plug it in for the variable y. We're plugging one equation into the other. We're substituting in. So here we go. We get the second equation ready to plug in all of that. So the 2x minus 10, since y is equal to all of that, we can plug it in for y. So from here, we just start distributing. We're going to get x minus 8x plus 40. Do you see how that worked out? Negative times a negative equals positive 40. And then we can combine these like terms right here, x and negative 8x, combine to make negative 7x. And then we minus 40 from both sides. We get negative 7x equals negative 35. Divide both sides by negative 7. And we're going to get that x equals positive 5. So all that work, that's only half an answer. That's my x value of the xy coordinate pair. Now I need the other one. So I'm going to go rewrite the equation again, y equals 2x minus 10. Why did I pick this one to plug back into? Because I could use either. I'm going to pick this one because it's a little bit shorter, smaller, easier to plug into. So 2 times 5 is 10. 10 minus 10 is 0. And hey, that's allowed. It just means that we're going to have two lines that touch at the coordinate 5, 0. How'd you do? Okay, good. So let's go ahead and take a peek at this next one. Notice that the next one is not set up the same way as part A. The next one is set up nicely for the elimination method. How do I know when it's set up nicely for the elimination method? Remember, it's in standard form. This is standard form where it's some number x plus some number y. Sorry. Oh, this is all freaking out. And it also is lined up nicely, possibly with opposites. So see how right here, you can see that 4 and 4 that can cross out. So that's how we know it's set up nicely for the elimination method. So we're going to be able to eliminate one variable to start, and then we add up the rest. This is called linear combination. We're going to say 5x plus 6x is 11x, and 3 plus 30 is 33. And so x equals 3. Now, going back to plug in the x equals 3, I can use either equation. I can plug it back into this one, or I can plug it back into this one. It's your choice. Doesn't matter. I'm just going to go ahead and pick, I don't know, I'm going to pick the bottom one. Okay, so here I go plugging in the 3 that we just got for x. So this right here is going to plug in here for x. And now we're going to go solve. 6 times 3 is 18. Let's minus the 18 from both sides. Divide by 4. And so we got that x is 3 and that y is 3. So our final answer we put together in coordinate pair as 3, 3. Okay, pause the video and go try to see what would I need to multiply the next two. I have to multiply the row by something in order to get the opposites. All right, let's see how you did. Notice in this first one for the x's, there's a negative 3x in the bottom, and I really wish there was a positive 3 up here. So that's what we're going to choose to multiply by to make those opposites. So 3 times x makes positive 3x. 3 times negative 7 is negative 21y. 3 times 6 is 18. Well, this is weird. Check it out. Notice that the 3x and the minus 3x cross out. We eliminate that. The 21 and the negative 21 cross out. And then the 18 minus 18 also cross out. This leaves us with a statement of 0 equals 0. Well, what the heck does that mean? It's always true, that statement. So we say that this system has infinite solutions. Okay, so if up here, in this example, we only touched in one place at 5, 0, imagine those two lines and how they intersect at one place. So if this next one over here touched at 3, 3, imagine that there's two lines and they intersect only at one place, right? At 3, 3. So then this one has infinite solutions. What would that look like? It literally means that the two lines are the exact same line. Like if I graphed those, I'd graph one line and then graph the other, and they would be right on top of each other. And so that means that every single point is the same because they're literally the same lines. So if you get a statement like 0 equals 0, that means infinite solutions because they're the same line. Let's go do this next one. Notice up here I've got this 2x, and I wish that down here I had a negative 2x. So that's how we choose that we're going to multiply the bottom row times 2, because 2 times negative x gives me that negative 2x that I want. 2 times 2 is 4. 2 times 4 is 8, sorry. So check that out. How'd you do? Now I'm writing the original other equation, and now we can see that we do have something to eliminate. So 4 minus 3 is 1y equals negative 4. And then I plug this back into either equation to see what I get for the other variable. All right, so x is 4, y is negative 4. This is another two lines that touch in one place at negative 4, 4. How'd you do?